quick show of hands, how many people have actually hand-coded SVGs? Okay, 3, 4. How many people didn't even know you could open an SVG and hand-code it? That's it. Everybody knew you could. I didn't really need to know that, but I just wanted to see some hands go up to make sure everybody was awake at 3 o'clock on Friday. So artisanal hand-coded data visualization. You might not need D3. Understanding how to write SVGs by hand has a number of benefits, such as performance, optimization, and the ability to use JavaScript to create, update, and interact with the SVGs. I'm always looking for ways to reduce the need for third-party interactions, and this is one. I'm just going to, the main topic is a summary of the features of SVG. I'm a Philadelphia native, quick intro, Philadelphia native who uses his artistic training and software development skills for Fortune 100 companies in the technology, media, and finance industries. Web developer since 1998. It's a weird flex because a lot of the technologies are completely different. Recent projects that I've worked on are various applications in the observability, developer experience, machine learning, and design system space. This is going to be real quick. If you think of me at all, think about user experience, design thinking, user interface design, front-end development, and data visualization. I was trained as an artist, so I tend to approach things from that direction, but it's really just the same thing said in different ways. Great art exposes the human condition. Great design attends the user experience. I originally intended this to be a lightning talk about data visualization based on a previous lightning talk that I gave about SVGs. I was able to cut the original 22-slide SVG presentation down to about 60 slides. So the purpose of data visualization is to turn data into something that people can understand and hopefully immediately at an intuitive level interact with. When I first joined the observability team, I needed to learn how to address the human data interaction. You take raw data, display it, and help someone understand and learn how to come away from that interaction changed. Coming from an art background steeped in technology, trying to represent vast amounts of data isn't a problem that you normally encounter. The first job of design is communication. Whether you're designing teapots or doors or software applications, a designer needs to communicate with another person how to use an object merely through the design of the object as much as possible. I was already familiar with SVGs, but that's when I first began learning D3. In my research, I came across the following quote. The trouble with D3 is to build a visualization, you must also have a deep understanding of SVG, DOM, JavaScript, geometry, color spaces, data structures, the standard model, and quantum physics. The standard model is the theory in particle physics describing fundamental forces in the universe, so I think he was being hyperbolic to make a point. In reality, I'd swap out the standard model and quantum physics with psychology and cognitive science. He specifically calls out D3, but that's really the trouble with building any data visualization for the web. DOM, JavaScript, color space, data structures, it's all just front-end development in general. The phrase, a deep understanding of SVG struck me though. I don't believe that it's necessary to have a deep understanding of something in order to have a useful understanding of something. Josh Kaufman wrote The First 20 Hours, based on the belief that you can become merely useful in a skill in the first 20 hours of focused learning. He sets up principles for effective learning and teaches himself programming, touch typing, the ukulele, among other things. 20 hours. You could get a basic grasp of something within a standard work week or an intensive weekend. I wouldn't call it expert level status, but it's definitely making someone knowledgeable enough to be useful. Some of it's already built into our front-end knowledge. Does it really take 20,000 hours to master a skill? Yes. Is it a deep understanding? Is a deep understanding needed to be useful? No. So I went through the first thing you need to understand to get started is what you need to learn. And for data visualization, geometry, document object model, color theory, JavaScript, SVG, data structures, cognitive science. I'll touch on all those topics as they relate to SVGs. Most of it's already covered by your average front-end developer. This is really a summary of a summary of a summary, so the pace might seem fast. We've got 60 slides to go through. But this will at least give you a start for your 20-hour journey. Let's address SVG first. This is a block of SVG code that will display a close icon. This isn't a made-up scenario. This is literally an SVG image that was sent to me by a designer. It was exported from a vector design application. There's nothing inherently wrong with it. It works. It has a smaller file size than a comparable raster image. The image itself looks fine. The normal workflow for images goes something like this. A designer gives a developer an image, and the developer puts the image online, sometimes without even resizing, cropping, or optimizing it. Many developers won't bother opening this file. Some developers don't even know that you can hand edit SVG files. Others look at the code in the file like this and just walk away. It can look overwhelming. This is the minimum viable code to display that same SVG image. One of the first things you'll notice after all the cruft is cleared away is that the SVG code is very similar to coding HTML. By simplifying the code, we're enhancing the developer experience. The average front-end developer could get the gist of how this works by playing with it for a few minutes. If I wanted a developer to change the color, he'd be able to open it up, find where the color's being set, and swap it out. It's easy to see that by hand coding the SVG, we have a smaller file size and less maintenance. Once you understand how to hand code SVGs, it opens up a world of possibilities to create, update, animate, and interact with them using CSS and JavaScript. Since it's XML-based, just like HTML, elements in SVGs work very much like elements in HTML. The SVG DOM builds on and is compatible with the HTML DOM. Because SVG code is so similar to HTML and the browser companies are kind, we can write SVG code directly in an HTML page or as a separate file. Standard front-end considerations still apply: usability, accessibility, security, and responsiveness. So there are a number of elements that come in SVGs, just like your div or your span tags for SVGs. Some of the most common you'll see will be line, rect, circle, text, path, and there are a number of others. Take the line, for example. If I were to give that to any developer familiar with HTML, they wouldn't be confused about how it works. They understand geometry, basic Cartesian coordinates, x, y values. You plug in a value into x1 and y1 and x2 and y2, and you end up with a line path. Likewise, they'd certainly have no issue with a rectangle element, the rect, x1 for the x origin, xy for the x1 for the x origin, and y2 for the y origin, a height and width. The circle element has attributes for center x, center y, and the radius. Text, it's difficult to do advanced typography in SVGs. The text element doesn't flow the way it would in an HTML document, but for doing labels, as you would or headers, it's sufficient. And the path element is really the workhorse of SVGs. I want to dive a little deeper into that. The basic path element is made up of the path tag and then the D attribute. You put different commands into the D attribute to tell the line where to draw. The spacing in the D value doesn't really matter. You could replace the spaces with commas or the commas with spaces. It would still process the same way. I like to put the comma in there to designate XY values or XY pairs. M is for move, L is for line. You can use an absolute or relative command. Capital M is absolute move from the 0, 0 origin. Lowercase m is a relative move from the previous point. And the previous point, when you start off a path, is always 0, 0. C and Q are commands to draw Bezier curves. That's pretty much all there is to that. The C command draws the handles with the lines with 2 handles, and the Q will just have 1 handle. What's displaying here right now would be the cubic Bezier. You can draw a circle using only Bezier curves, but the arc command makes it easier. That's especially important when drawing something like a pie chart. When you string enough points together, you end up with a complex shape. Ooh. There's an image tag that you can use when you pull in, if you need to pull in raster images. And you can even take those raster images and make a data URI to embed them in the SVG. Beyond the drawing elements, there are actual elements to create gradients and tiled patterns. It's HTML at the very beginning started to go down a similar path where they would have elements to change the display of the code, like the font tag. SVG just seems to have used that pattern. It's nice to have a declarative way to add a pattern to a page. In the pattern element, it's explicitly for creating pattern backgrounds. You put some SVG code in the pattern element, and you can use it to fill in the XY directions indefinitely. There are actual elements for animation. This is the animate element, and by setting the attributes for the attribute of the parent element, you can change the values of those over time. In this case, I'm changing the radius of the circle and the opacity of the circle. So just over with the attribute name, the duration, and repeat it forever. You can designate motion paths up in a defs section, similar to how the head is used in HTML. You put all your definitions of different things that you would want in the code, but not displayed. It's a place where you put your filters, your patterns, your gradients, and in this case, a motion path. And so this is a GIF image because Google Slides doesn't accept SVGs. The GIF image is actually 1.7 megabytes. The full screen HD quality SVG is 14K. So here are the filter effects. You can use filters to create drop shadows, glow effects, turbulences, displacements, and more. You can even simulate traditional art media like paper, charcoal, or watercolor. You can composite and merge the effects into a single image. Deceptively, sometimes you'll see an SVG that doesn't even look like an SVG. I like the little bunny cloud. Onto CSS. A lot of the properties or attributes that you use in SVG, you can directly interact with in SVG. Or you can directly interact with in CSS on the SVG. You can also write media queries directly in the SVG. You can write a single image that, based on the size of the image that's being used, set the max width, and have different images appear, or prefer color scheme works, probably any other media query. Test them out for which ones you like. And of course, there's an anchor tag that you can put directly in the image. It won't work if you attach the SVG into the page through an image element. You need to either use an object element or directly add the SVG inline into the SVG. JavaScript. Interacting with SVGs are using JavaScript is almost identical to how you would use it in HTML. One thing you should note, though, is that you should include the C data script within your script tag within the SVG, because it's XML based, but it's not exactly like HTML. So you either have to escape the character with ampersand or with an HTML entity, or through the use of the C data. Just like the anchor element, the JavaScript only works if it's embedded in the page or if you're using the object element. Okay, so when you're creating an SVG element, you need to use a special create element namespace method on the document and pass in the SVG namespace. Otherwise, you won't be able to do very much with it at all. There's also the set attributes namespace alternative. I find that you can usually just use the set attribute when you're creating or setting attributes to your elements that you create. In this case, I'm creating an SVG element using the SVG namespace, adding an ID attribute, a viewbox attribute, and setting the height and width of the SVG. Oof. So this is the code that you would use to draw a simple line. Document, create an element namespace, pass in the namespace, tell it which element you want to create, and then set the attributes for the X, Y, X1, X2, Y2, and whatever other attributes you want to add to it. Skipping a huge step, you can create elements and start making generative art. The script here is just a pseudocode of creating a path that you'd be able to put into put into your SVG to automatically create the images. There are a wide variety of built-in SVG methods. Can't go over each one individually. DOM point and get screen CTM are important ones you'll probably use. The get screen CTM is really the point where the client cursor is interacting with the SVG. Event listeners work just like you'd expect. Here I'm using some of the SVG methods to get the position of the cursor on the click. It may require a little bit of juggling with pointer events, but you can, which can be applied through the SVG attributes or through SVG properties. Here I'm turning off the pointer event on the text element so that you can click through it. It won't capture the click when you click on it. Otherwise, if you don't turn off the pointer events, you won't click through and you won't know why your button's not working. The code for this is a little bit too long for this slide, but on an HTML page, you can bind your inline SVG elements to input elements, pass in and change the attributes, and create utilities like a polygon point visualizer with a basic understanding of geometry, trigonometry, and some help from your child's high school teacher. You can make something just like this. Oh, this is so much harder. I'm not going to boop 10 moles. Okay, I give up. Let's get back to the presentation. So you can create objects in SVGs. You can bind those objects to interactions. SVG contains all the features you need to make a self-contained interactive environment. Flash allowed developers to create self-contained applications that required a plugin to work. Now we can create that directly in an SVG. And again, I have a repository online that you can jump to anytime I add. Eventually, what's in this presentation will be added to that. It's kind of a mess right now, work in progress. But we want to talk about data visualization. Elegant design requires us to think about a theory of graphics, not charts. The full quote is, "There's also a practical reason for shunning chart typology. If we endeavor to develop charting instead of a graphing program, we will accomplish two things. First, we will inevitably offer fewer charts than people want. Second, our package will have no deep structure. Our computer program will be unnecessarily complex because we will fail to reuse objects or routines that function similarly in different charts. We will have no way to add new charts to our system without generating complex new code. Elegant design requires us to think about a theory of graphics, not charts." He's saying, don't put the chart before the horse. No. So when building graphics, I don't even see the code anymore. All I see is a line element, React, ArcPath. You go from looking at a data visualization, not knowing how to replicate it, to seeing the structure and understanding how it could be built. Falling back to the JavaScript to create a line, collect the values on the x-axis, display them across the y-axis, and you can create a line on a line chart. If you remove the lines, you can create what amounts to a scatter plot. You have to calculate the y position against the height of the bar to place bars at the bottom, but just passing in the values of the height, you get a simple bar chart. Leyland Wilkinson made an assertion in the Grammar of Graphics. It's easier to graph Newton's law of gravitation than to draw a pie chart. The pie chart's a lot more complicated than the bar or the line chart, but it still only requires 3 points to create the arc, the center point and the two side points, and a little bit of additional code to make the actual curve. I've seen front-end developers torture themselves making data visualizations with divs and GIFs and convoluted CSS. Building an animated gauge is almost trivial with SVGs, no framework or libraries needed. This is the same basic code that I made in 2017. It's just a series of circles with stroke widths, setting the actual values on the gauge. Remember the polygon point visualizer? Create a polygon, rinse, repeat, and you create a hexbin chart of the United States. Once you understand the underlying structure of SVGs, you can use pre-existing art to make your data visualizations. This was a map taken directly from Wikipedia. Almost time? Okay. 5 minutes. Okay. You distracted me. Sorry. You don't actually need to pull in a framework to render the geographic data or hand draw New York. If you can recognize which path element is drawing New York, then you can write the code just to change the color based on the data that you pass in. Understanding the basic of SVGs, then working with D3 becomes a lot more understandable. There's nothing in here that couldn't have been done with a plain SVG, but D3 definitely made it easier to convert the GeoJSON data into SVG coordinates. If I were to build a component that shows different cities, I would just pull in the GeoJSON data using the D3's GeoJSON plugin and display different cities. Note, stay out of Logan Circle tonight after the party. So that's geometry, SVG, the DOM, color spaces, a few more items, mainly just to show some pretty slides. My art professors were always going on about how great artists were trying to capture, represent, and express the human condition. It's just another avenue into user experience. Fine art, commercial art, illustration, graphic design, front-end development, they all more or less have the same goal: communication. Good design communicates well. A handle on a mug isn't just a handle, it's the designer telling you this is a good place to hold the mug. Path, rect, circle, text elements are gathered together to tell a story, hopefully to make you laugh. If you possess a basic level of data visualization literacy, then you understand this message. I could tell you I don't understand pie charts, but that wouldn't be a memorable experience as this chart. It's likely you'll remember this chart long after you've forgotten my name. Data visualization, wow, all the beats are falling. Data visualization is attempting to solve problems in human data interaction. It's a central problem experienced by traditional artists and designers and front-end developers and data visualizations. This is a chart component I made for my personal site. It's a hand-coded SVG written into a React component. It doesn't use any third-party data visualizations package because it doesn't need it. A few lines of JavaScript code, I can pass in the data and make the charts personal. Initially, when I was building this chart, I didn't have, it wasn't making sense until I wrote a JavaScript function to get the viewer's browser information and make it a point of interest in the chart. If I were to tell you that these faces represented data coming from 3 different servers, what could you tell me about them? In 1973, Herman Chernoff thought that we could represent multivariate data in the form of faces based on the fact that a large portion of the human brain is devoted to facial recognition. The data visualization structure is called the Chernoff face. The goal is to make visualizations that are intuitive at a glance. We can make abstract charts and graphs when sometimes a little expression is all we need. I just wanted to post a pretty chart. Everything on here is SVG. All the stars, all the graphics, the galaxies. The aesthetic quality of a product is integral to its usefulness because products we use every day affect our person and our well-being, but only well-executed objects can be beautiful. This is Dieter Rams. This was an attempt, partial attempt, at what would look like network conditions through different connected items. And that's it.